We are going to talk about linear and quadratic approximation, or we are going to discuss how to find Taylor polynomial for function of two variables. Here you can see that x and y are the inputs, or the output can be set. So our target is to understand how to find Taylor polynomial for this function, or we can say what will be the Taylor series for this function. So you already have the concept how to find Taylor series or Maclaurin series for function of single variable. But now we're going to discuss how to find Taylor series, or say Taylor polynomial for function of several variables, or function of two input variables, or function of two variables. So in Taylor polynomial for function of several variables, or say two variables, there will be two concepts that you have to understand. You need to find first degree Taylor polynomial, and you have to find second degree Taylor polynomial. So first degree Taylor polynomial is known as L of x comma y, and second degree Taylor polynomial is known as Q of x comma y. Why we are using L for first degree Taylor polynomial? First degree Taylor polynomial can be also called linear approximation for function of two variable, and this for second degree Taylor polynomial we can say it is quadratic approximation. So you can see that L and Q. So we are taking the first letters. So first degree Taylor polynomial can be denoted by L of x comma y. Second degree Taylor polynomial can be denoted by Q of x comma y. At first, let us recall what is polynomial. Polynomial can be constant, can be linear, can be quadratic, can be cubic, it can also be quartic. So constant is also known as zero degree polynomial. Linear is known as first degree polynomial. See, for L of x comma y, that is linear approximation, it is written that it is first degree Taylor polynomial. So linear is also known as first degree polynomial. Quadratic means second degree polynomial. Cubic means third degree polynomial. Quartic means fourth degree. So if we want to find more, we can say fifth degree, sixth degree, finally nth degree polynomial. But the first five polynomials has some alternative names. That means 0 degree is known as constant, first degree is known as linear, second degree polynomial is known as quadratic, third degree is known as cubic, fourth degree is quartic. But for fifth, sixth, 7th, or in general case we can say nth degree polynomial. For this higher order parts there is no specific name, we can call by what is the degree of that polynomial. Based on the degree we can call it is nth degree, or let's say 5th degree, 6th degree, like that. Now let us have a look on the examples. What is constant or 0 degree polynomial? Say we have 2, or let's say we have -5. If we have a look, 2 can also be thought as 2x power 0. You know that x power 0 is 1. So that means if we think about x, the highest power of x is 0. That means x power 0 is 1. That's why it is 0 degree. The highest power of x in a term is known as degree of that polynomial. So since here we have x power 0, the power is 0, that means we can say 0 degree polynomial or a constant. What is linear? Suppose you have 5x negative 6. So here we can see that if we simplify again, it is 5x power 1 negative 6x power 0. 6x power 0 is 6. So how many terms we have? There are two terms, first term and second term. So there are two x here, x power 0, x power 1, but the highest degree is 1, not 0. So based on the highest degree, we can call this one as that degree polynomial. So since it is 1, 1 is the highest degree here or power, so that's why you can say first degree polynomial, or you can say linear. Similarly, quadratic will be x squared plus 5x plus 6. So here x power 1, x power 2, and for 6 it will be x power 0. So highest power is 2. That's why we can say second degree polynomial or quadratic. Similarly, we can think about x cubed plus 2x. Here x power 1, x power 3, highest power is 3. That's why it is third degree polynomial. Similarly, we can think about all the polynomials. But for this case, linear and quadratic approximation for function of two variables, we are talking about only linear approximation and quadratic approximation. That is linear and quadratic polynomials. So have a look here that if we have a look on the example of quadratic, x squared plus 5x plus 6, you can see that inside this term, inside this polynomial, there is a term 5x plus 6. That means inside quadratic polynomial, we have also linear polynomial. If we just consider about 5x plus 6, so this is the concept that you have to understand. For cubic, you will also have the previous polynomials. How? Let me show here. Here you have x cubed plus 2x. We can also think about x cubed, then 0 into x squared, then 2x plus 0. If we simplify, then we will get the same thing. But you can see that inside cubic, you have quadratic, you have linear, you have constant. That means the more you go, the previous terms will also come. So that is the concept that you have to understand. Whenever we will find quadratic, so at first there is L of x comma y, then something other with x squared or y squared terms. Okay, but you need to understand that if we have to find second degree Taylor polynomial, then at first we need to find the first degree Taylor polynomial or L of x comma y. So now I am going to write the formulas for first degree and second degree Taylor polynomials. Have a look here. So the formula or series for first degree Taylor polynomial of f of x comma y at any point a comma b. So what will be the polynomial? You know that we have already denoted first degree Taylor polynomial by L, or we can say L of x comma y. Okay, the short form can also be L. L means it contains two input variables. So L of x comma y equals, the first term will be f of a comma b. That means if you have f of x comma y, where you have x and y, you just need to replace them by a and b, then you will get f of a comma b. Then the next term will be f sub x of a comma b times x minus a. So now what is f sub x? You have to remember that if f is a function of several variables, that is two variables, f sub x will be the partial derivative of f with respect to x. That means we are differentiating f in terms of x. Partial differentiation will be done here since the function is of several variables. So whenever we are differentiating in terms of x, remember at that time the other variable will be constant. So y will be constant. Now have a look on the next term. The next term will be f sub y of a comma b times y minus b. This is the formula or Taylor polynomial. For what degree? It is for first degree Taylor polynomial, or we can say it is L. So let us write the second degree Taylor polynomial. Of f of x comma y at any point a comma b. So we know that second degree Taylor polynomial is known as q, or we can also say q of x comma y. So you know that for quadratic polynomial, that means that polynomial has x squared term. That's why we can say it is second degree or quadratic. So for second degree polynomial or quadratic, there is L. If we consider this one as L, that means for quadratic polynomial, you will also get L plus something with x squared or y squared term. So that thing is also applicable here. But at first, let me discuss about what is f sub y. Since we have f of x comma y, f sub y will be the partial derivative of f with respect to y. Since partial derivative is going on, so the other variable will be constant. So we are differentiating in terms of y, x is constant at that time. Now, what is q of x comma y? So whenever we are trying to find q of x comma y, it is sure that all these terms will come here. That means, in short, we can write L of x comma y plus, now I am going to write the next terms. But remember, if you are asked to find the second degree Taylor polynomial, at first you have to find all these terms that you have in L of x comma y. So all this will come here, plus 1 over 2 f sub xx a comma b x minus a squared. So 1 over 2 times f sub xx of a comma b x minus a squared. So what is f sub xx? It means you have to differentiate f sub x with respect to x. At that time, the other variable will be constant. So f sub x, already you have f sub x here. So in order to find f sub xx, you need to find first f sub x, then you can differentiate with respect to x. So this is important. The next term will be, let me write here, f sub x comma y of a comma b times x minus a y minus b. So now what is f sub xy? We have to differentiate f sub x with respect to y. Partial derivative is going on. We are differentiating in terms of y. Then x is constant, remember. So this is the term. This a comma b is not in multiplication form. This is not like that. If we think about f of a comma b, similar thing is going on here. That means we have to find f sub xy of a comma b. That is okay. Now let me write 1 over 2 f sub yy of a comma b times y minus b squared. So you can easily remember this one. At first, 1 by 2 f sub xx times x minus a whole squared. Similarly, there is another term, 1 over 2 f sub yy times y minus b whole squared. So what is f sub yy? It means you have to differentiate f sub y with respect to y. Partial derivative will be done here, so the other variable is constant. You are differentiating in terms of y, so x will be constant. So this is done. You will be asked to find what is L, or first degree Taylor polynomial, or find the linear approximation of the function. You have to find L. If you are asked to find the second degree Taylor polynomial or quadratic approximation for function of two variables, then you have to find Q. So Q equals L plus some other terms, and that terms are here. So these are the two formulas that you have to remember always. So we can write one example here. So suppose we are going to find the first and second degree Taylor polynomial of a function f of x comma y equals x e power y at any point 1 0. So the question is, we have to find L and Q of f of x comma y equals x e power y at any point 1 0. So this is our function, and here we have a point. You can have a look on the main formula. Here we have a point a comma b, and there is a function here with a point. So similarly, we have a function here with a point. So if we compare with a comma b, then you can easily understand that a equals 1, b equals 0. So these are the information that we have already. Now let us try to find L and Q. So you can see that inside L, you have f sub x and f sub y. So you have to find these functions at first. That means you have to find the partial derivatives. So let me write here. We have the main function f of x comma y equals x e power y. This is our main function. So if we have a look on L, first we have to find f of a comma b. So have a look on the letter f. So here we have f. That means from this part we can find f of a comma b. So what is a and b? A is 1, b is 0. That means we have to find f of 1 comma 0. So that means where you have x, you need to input 1. Where you have y, you need to input 0. So x, that is 1 times e power 0. E power 0 is 1. That means the result is 1. So we have found the value for f of a b, or f of 1 0. It's 1. So let me write the formula again in another page so that you can understand. So we have found this one. The value is 1. We are going to have L of x comma y. So it will be f of a comma b. That means f of 1 comma 0. So I am writing the formula in simplified forms. So f sub x 1 comma 0, x minus a is 1, plus f sub y ab, that is 1 0, y minus 0. So this is the thing that you have to rewrite. Let me write again f of 1 comma 0 plus f sub x 1 comma 0 times x minus 1 plus f sub y 1 comma 0, y minus 0 is y. So our target is to find this one, and this one, and we don't need to change these terms. This will be same as it is. So we have found already f of 1 comma 0. this is 1. So let me write here. I am solving the problem slowly so that you can understand the total thing. So this is 1 plus, we need to find what is this, and there is x minus 1. We also need to find what is f sub y. So you can see that we have to find f sub x and f sub y. That means we have to find a partial derivative of this function. So let us find the partial derivative. So f sub x, it means we have to differentiate f with respect to x. You can understand one thing, that every time for partial derivative I am using a circle here. You can see every time I have used this type of notations just to understand which function is to be differentiated. So for simplicity, I can tell you that if you have f sub x, y, leave the last term and give one circle mark so that you can understand that you are going to differentiate f sub x with respect to y. Suppose you have f sub x, x, y, then what you have to do? It means you are going to differentiate f sub xx with respect to y. So always leave the last variable and give one mark, circle mark, to understand which function is to be differentiated. So we are going to differentiate f. There is no need to write this one. You can do this with your pencil. Okay. So we are going to differentiate in terms of x. So remember, y will be constant. I am using the short form of constant, that is CONT, constant. Okay. So d dx of f, that means d dx of x e power y. So since y is constant, so e power y will be constant. We can bring e power y before the derivative. Now you know that differentiation of x with respect to x is 1. So we have e power y. So this is coming from this part, it is f sub x. Now I can say that f sub x is also written as f sub x, x comma y. Okay, this is the short form of f sub x, x comma y. It means where you have the short form L, always remember that you have x comma y there. Okay, because this is a function. So f of x comma y is the function of two variables. Its first derivative or partial derivative will also be a function of two variables. Now have a look here. We need to find f sub x at 1 comma 0. So here we have f sub x. Okay, so now we have to find f sub x at 1 comma 0. So where we have x we need to input 1. Where you have y, we need to input 0. So in right side, we have just y term. There is no x term. So there is no problem. We can just input the value of y. E power y means e power 0 equals 1. So finally, we have found what is f sub x at 1 comma 0. It is also 1. So f sub x at 1 comma 0 is 1. We need to find now what is f sub y at 1 comma 0. That means the short form is we have to find f sub y now. So let me do this one again. So we are going to find f sub y. So which function I have to differentiate? I have to differentiate f with respect to y. Since I am differentiating with respect to y, so x will be constant. Now, it means I am differentiating f with respect to y. So what is f? F is the main function x e power y. X e power y. Partial derivative is going on. So the other variable will be constant. X is constant. That's why we can pull out x before the derivative. We have just e power y. So you know that ddx of e power x is e power x. Similarly, ddy of e power y, if the variables are same here, you will get the same thing. So we have the same concept here. Derivative of e power y will be e power y. So it is coming from f sub y, or we can think that f sub y is a function of x comma y. Now you can see that we have to find f sub y at 1 comma 0 point. So let me find this one, f sub y at 1 comma 0. Where you have x, you need to input 1. Where you have y, you need to input 0. So x means 1, e power y means 0. So 1, and this is also 1. Finally, you will get 1. So you have found what is f sub y at 1 0 point. It is 1. So we are now ready to write the final polynomial, which is known as the linear approximation or first degree Taylor polynomial for function of two variables x e power y. Let me write this one now. 1 plus 1 times x minus 1 is just x minus 1 plus 1 times y. This is just y. So this is our result. Done. We can say that this is the answer. But we can also simplify if we want. Say we are trying to sum up all these things, x minus 1 plus y. So 1 and 1 can be cancelled. You have just x plus y. So you can see that this is also our answer. If you keep your answer here, that is also okay. If you simplify, that is also okay. Okay, but the thing is you have to follow this process. You need to find f at 1 0 point, f sub x at 1 0 point, f sub y at 1 0 point. So Whenever I have given the definitions of polynomials, you have seen that for linear polynomial, x has power 1. The highest power is 1, and here you have x power 0. So the highest power of x is 1. That means linear polynomials involve power 1. So you can see that since this is function of two variables, so both x and y have powers 1. So that's why it is known as linear polynomial. Now we have to find what is q. That means our target is also to find q. We have already L, and let's find q. So what is the formula for q? This is the formula for q. I'm going to copy this one. Let me write L at first because already we have L. So L is x plus y. We know that what is L? L is x plus y. This is written here. Now we have to find the other things. 1 by 2 f sub x at a comma b. A comma b means 1 comma 0 because you have a value is 1, b value is 0. So I'm just inputting what is a and what is b with x minus a whole squared. So that means x minus 1 squared plus let me make it more compact. So then you have f sub xy at 1 comma 0. X minus a means x minus 1. Y minus b means y minus 0. So this is also done. Plus we have 1 by 2 f sub yy of a comma b means 1 comma 0, y minus b squared, that is y minus 0 squared. So now we need to find the unknowns. F sub xx, f sub xy, f sub yy. So q equals x plus y plus 1 by 2 f sub xx 1 comma 0 x minus 1 squared plus f sub xy 1 comma 0 x minus 1 y minus 0 is y. That's why I have written again this one, because you need to simplify always. Plus 1 by 2 f sub yy 1 comma 0 y minus 0 squared means just y squared. So now we have to understand which are the unknowns. This is f sub xx, f sub xy, f sub yy at 1 0 point. Okay, we need to find this. So these are the unknowns. So we have to find this one. Now let us have a look on f sub xx. So f sub xx. Now you have to understand that which function I have to differentiate, f or f sub x. You have already seen that I always do partial derivative by leaving one variable, that is the variable that is on the right side. I always leave that one and make a circle for the previous part. So then you will understand that which function I have to differentiate. I have to differentiate f sub x with respect to x. So I am going to differentiate f sub x with respect to x. Since partial derivative is going on, so y will be constant. Now ddx of f sub x, we have f, but we don't need to input f here. We have to input f sub x. This is important. Okay, so have we found f sub x? Yes, we have found f sub x. This is this one, f sub x, or this one, it is e power y. So we have to replace f sub x with e power y. I hope you have understood this one. So since y is constant, e power y will also be a constant. So the derivative of e power y or derivative of constant is 0. So f sub xx equals 0. That means f sub xx of x comma y is also 0. Now we have to find f sub xx at 10 point. 10. So x is 1, y is 0. But since the right side is 0, so f sub xx of 1 comma 0 will also be 0. So this is the thing that we have found for here. Now we have to find f sub xy. So f sub xy. Again, you will understand that I am going to make a circle leaving the right variable here. So I will understand that differentiation will be for f sub x with respect to y. So ddy of f sub x. So what is f sub x?
e to the power y.
E power y. Thanks. It is e power y. So remember, we are going to differentiate in terms of y. So x is constant. This is e power y. Now it is coming from this part. It is f sub xy equals e power y. Or if we write more information on it, then it will be f sub xy at x comma y equals e power y. Now we have to find f sub x y at 1 comma 0 point. So x is 1, y is 0. We have only y here, e power y, so e power 0 equals 1. So this is 1. F sub xy at 1 comma 0 point is 1. So this is 1. Now the only thing that is left, we have to find f sub y. So let me do this one here or here. F sub y. Now you have to understand that we are going to differentiate f sub y, derivative of f sub y with respect to y. So ddy of f sub y d dy of what is f sub y? We don't need to input f, but we have to look for y, f sub y. So that is important. So we have already found what is f sub y. Yeah, this is the thing, f sub y. That means f sub y is x e power y. So x e power y. Now you have to understand we are differentiating in terms of y. So x is constant. Since x is constant, we can pull out x before the derivative. So x derivative of e power y with respect to y will be same. So we have found f sub yy or f sub yy at x comma y. So done. Now our target is to find f sub yy at 1 comma 0 point. So f sub yy at 1 comma 0, where we have x, we will input 1, where we have y, we will input 0. So 1 e power 0, that means 1. Every time value is becoming 1 or 0, but that is not a matter. Okay, you need to find the value. It may be 1, it may be 2, it may be 0. It is up to the calculation. Okay, don't think that every time we will get 1. No, based on the calculation, what value you will get, that is the answer. So this is 1. Now let's input 1 here and we will simplify so that we can have the quadratic polynomial q. So this is 1. Now we can simplify. Already we have the linear polynomial L, that is x plus y. Then 0 times 1 by 2 times this one. This will be 0 plus 1 times x minus 1y. That means we have x minus 1 y plus 1 by 2 times 1 times y squared. It will be directly y squared by 2. Now we can simplify more. Q of x comma y equals x plus y. We don't need to write 0 again. I am going to write directly x minus 1y plus y squared by 2. So since we have q here and this part is L, so L plus something, you can understand that we have already y power 2. Since we are going to find quadratic or second degree polynomial, we can see we have found y power 2, and also there is another term x times y. We can keep our answer here, or if we want we can also simplify more. So it is x plus y plus xy negative y plus y squared by 2. So this is our final result. Okay, now you can see that for second degree polynomial we have y power 2. Also we have a product term x power 1 y power 1. 1 plus 1 is becoming 2. That means in second degree polynomial, for function of several variables, you need to have also product terms. So we can also keep our answer here, or we can also simplify more. If we cancel out y and y, we will get x plus xy plus y squared by 2. That is also okay. So once you will have applied the formula and you have all the values, you can also keep your answer here. No need to simplify this one. Okay, you don't need to do these calculations. So this is what we know as Taylor polynomial for function of several variable or function of two variable x comma y, which is also known as linear and quadratic approximation for function of two input variables. So I hope you have understood all the concept. Thank you.